Okay, Algebra 1, today we are solving inequalities and graphing them on a coordinate plane. And remember, anytime that you solve an inequality, you are trying to get the variable by itself or the y on the left side, and you put it in slope-intercept form. Sorry, I was stuck on equations for a second. So the first thing we're going to do is we're going to move the 1/2 x over to the right side. So since it's positive, I'm going to subtract it, and that makes this whole thing go away. I'm going to write minus 1/2 x underneath there. So I'm left with negative 2y. Is less than or equal to negative 1/2 x minus 4. Now I need to get the y by itself, so I'm going to divide by negative 2. That cancels that out. I'll be dividing both of my terms by negative 2, like that. So when I go to write it, I notice that I divided on both sides by a negative, so that makes my inequality sign flip, so it looks like that. To do the negative 1/2 divided by negative 2, just think about it like fractions. So if you had this, you would change the division to multiplication and flip the second fraction. And you have to think about that over 1. And so then we just multiply across and we'd end up with 1/4 positive because it's negative times the negative. So I now have 1/4 x, and then negative 4 divided by negative 2 is a positive 2. And that is what I'm going to be graphing on my coordinate plane. So I'm first going to go up 2 on my y-intercept, because the y-intercept is 2 right here. And then I'm going to do a slope of 1/4. That means up 1 to the right 4. So up 1, 1, 2, 3, 4. Put a dot there. I can't do a second one, so I'll leave it like that. And now I look at my inequality sign, and it is greater than or equal to, which means it's a solid line. So I'll draw a solid line going through those. And now the last thing I need to do is shade. It's greater than, so I'm going to be shading above. So above the line would be like this. So I'd shade this whole area like that. And that is the graph of this inequality. And now the last thing you want to do is do a test point. And if we use 0, 0, if we look at the graph, 0, 0 is not in the shaded region, so 0, 0 should give us a false statement. So I'm going to go ahead and erase all this work right here. I'm just going to put in 0, 0 for my x and y. So I'd have 1/2 times 0 minus 2 times 0 is less than or equal to negative 4. 1/2 times 0 is 0. Negative 2 times 0 is 0. So I'd have this. So I end up with 0 is less than or equal to negative 4. And since negative 4 is the smaller number, this is a false equation, which means that our graph is correct because it should have been false since 0, 0 is not in the shaded area. Okay, so we did everything right, we tested it, and that's it. Looking at a couple other examples here, I have y is less than negative 3. So I can go straight to my graph because I don't need to put it in slope-intercept form since it's just a y line and there's no x in this equation, which means that this is a horizontal line at negative 3. But what kind of line is it? Since it's less than and not less than or equal to, it's going to be a dashed line. So I'm going to find my negative 3 on the y-axis, which is going to be right there. And I'm going to do a dashed line across there, like that. Draw arrows on both ends. And now I'm going to shade. I want everything less than that, which means everything below the line. And everything below would be down here. So that is the answer. Looking at the next one, we have x is greater than or equal to 4. Again, you will notice that there's no y, so we don't need to put it in slope-intercept form. And next line is a vertical line. The vertical line is going to be at 4. So I'm going to go over to 4. Now what kind of vertical line am I going to have? Since it's greater than or equal to, we have that line or equal to underneath. It's a solid line. So I'm going to draw a solid line through 4. Now to show where we graph, since it's greater than or equal to, we need to show everything bigger than 4, which is going to go on the right of it. Best way to think about that is all of these x's are going to be bigger. So like the next one is x is greater than 5, or x is 5, x is 6, x is 7. So if you think about the ones that are next, then that should make it make sense. So that is the graph of that one. I have one more, just because I think you have a few like this. Okay, now I do have a y and an x, so I'm not going to have horizontal or vertical, but the first thing I need to do is get my y by itself. So I'm going to divide by negative 3 on every term I have, and I only have that term and the x term, so I'm going to do that. Now I am dividing on both sides of the inequality by a negative number. So I'm going to flip my inequality sign around. And negative 6 divided by negative 3 is positive 2. So I'm going to write 2x. So y is greater than 2x. So if you have one like this, and there is, the first thing you do when you go to graph it is you graph the y-intercept. There's no y-intercept here, so it's understood to be plus 0, because if there's no y-intercept, then the y-intercept is 0. It's not really that there isn't one, it's just 0, and so they don't show it in the equation, or inequality in this case. Okay, so now we're going to do our slope, and our slope is what's in front of the x, and so we have a slope of 2, positive 2, and of course it's 2 over 1, so that means we're going to go up 2 and to the right 1, and so I'll do it twice, and I'll get that right there. And so then I look at my inequality sign to see what kind of graph I do. Since it's just greater than and not greater than or equal to, it'll be a dashed line. So I'm going to draw dashes through those points, draw a couple arrows, and it's greater than, so I need to show everything above it. And on this graph, the things that are above it will be this way. If you can think about it, where would anything above is going to be where slope man would be walking. Anything below would be on the opposite side of where slope man would be walking if he was going on the slope. Okay, so that might help you out a little bit there. Okay, that's the last example. If you guys have any questions, oh wait, let me do a test point real quick. Okay, so it's kind of hard to think about 0, 0 because the dashed line goes right through it. But if you think about that, it should make a false statement because the dashed line goes through it, not a solid line, which means that it can't be anything on the line, it's anything above the line. So if we did 0, 0 in our equation, it should make a false statement. So if I said negative 3 times 0 is less than negative 6 times 0, I end up with 0 is less than 0. That's false, which makes sense because if we go back to our graph right here, 0, 0 is on the line that we graphed because our line goes right through the origin. But our line is a dashed line, which means nothing on the line can be part of this solution. So I hope that makes sense, and I will see you guys tomorrow. Let me know if you have any questions.